What if we told you there are planets out there that make Earth look like a fixer-upper? Buckle up as we take a cosmic journey to explore astonishing new worlds scientists have just discovered, which could be even better for life than Earth. Don't miss out and let's get interstellar. Superhabitable planets are celestial bodies that hold the potential to provide even more favorable conditions for supporting life compared to Earth. While Earth is currently the only known inhabited planet, scientists speculate that there could exist other types of planets that surpass Earth's habitability. The search for superhabitable planets challenges the anthropocentric and geocentric perspective that limits our exploration of Earth-like worlds. In the quest to identify such planets, researchers analyze data from the Kepler Object of Interest Exoplanet Archive, focusing on planetary systems with rocky planets situated within the habitable zones of their host stars. Orange dwarf stars, which are cooler and have longer lifetimes than our Sun, are considered prime candidates for hosting life due to their increased stability and extended time frames for life to develop. Factors such as planet size, mass, and temperature play crucial roles in determining habitability. Larger planets with more habitable surface area, slightly warmer temperatures, and smaller continents may provide ideal conditions for the emergence and evolution of life. However, it is important to note that while superhabitable planets offer better conditions for life, the presence of life itself is not guaranteed. Further exploration and observations by advanced space telescopes are needed to confirm the habitability of these potential superhabitable worlds. Researchers propose that solely concentrating on Earth-like planets in the search for extraterrestrial life may restrict our understanding and exploration of exobiology. While Earth serves as our reference point for habitability, scientists argue that there may exist alternative types of planets with vastly different conditions that could support life forms beyond our current comprehension. By fixating on Earth-like worlds, we risk overlooking the potential diversity and adaptability of life in the universe. The concept of exobiology encourages scientists to broaden their perspective and explore the possibilities beyond our familiar parameters. It challenges the assumption that life can only thrive under circumstances similar to those found on Earth. To expand our search, researchers investigate various factors beyond mere similarity, such as the presence of liquid water, alternative chemical compositions, and the adaptability of life forms to extreme environments. This approach acknowledges that life may manifest in unexpected and unfamiliar ways. By considering a wider range of possibilities, scientists can enhance their understanding of the potential for life beyond Earth and increase the chances of detecting and comprehending different forms of exobiology that may exist in the vast expanse of the cosmos. Scientists rely on the Kepler Object of Interest Exoplanet Archive as a valuable resource in their quest to identify potentially superhabitable exoplanets. This archive serves as a repository of data gathered by NASA's Kepler Space Telescope, which observed a vast number of stars in search of distant planets. Researchers leverage the Kepler Object of Interest Exoplanet Archive to analyze and study planetary systems that are likely to harbor rocky planets within the habitable zones of their host stars. The habitable zone refers to the region around a star where conditions are favorable for liquid water to exist, which is considered a key ingredient for life as we know it. By focusing their investigations on this database, scientists can narrow down their search to specific planetary systems that hold the potential for hosting life-friendly environments. This approach enables them to analyze various characteristics of the planets, such as size, orbital parameters, and proximity to their parent stars, aiding in the identification of potential superhabitable candidates. The Kepler Object of Interest Exoplanet Archive provides a valuable foundation for further research and exploration, guiding scientists in their pursuit of understanding the potential prevalence and diversity of habitable worlds beyond our solar system. Orange dwarf stars, characterized by their cooler temperatures and longer lifetimes, are regarded as superior contenders for harboring life compared to our Sun. While our Sun, a yellow dwarf star, has been the focal point of habitability studies, scientists have recognized the advantages that orange dwarfs offer. The cooler nature of orange dwarfs allows for a more stable and prolonged habitable zone around these stars. This extended time frame provides planets within the habitable zone more opportunities for the development and evolution of life. Additionally, orange dwarfs have lifetimes that can span 20 to 70 billion years, far exceeding the estimated lifespan of our Sun. The prevalence of orange dwarf stars in the Milky Way further increases the likelihood of finding potentially habitable planets. They are approximately 50% more common than yellow dwarfs like our Sun, expanding the potential pool of worlds that could support life. By shifting the focus from our Sun to orange dwarf stars, scientists aim to broaden the search for habitable exoplanets and enhance our understanding of the conditions necessary for life to thrive. Exploring these stellar systems unlocks new possibilities and opportunities for discovering extraterrestrial life in the vast expanse of the universe. Larger planets that possess greater habitable surface area and slightly warmer temperatures have the potential to be classified as superhabitable. While Earth-like planets have been the primary focus of habitability studies, scientists suggest that expanding the scope to include larger celestial bodies with specific characteristics could unveil even more favorable conditions for life. A larger planet offers a greater surface area, providing more room for potential habitats and ecosystems to thrive. This increased habitable space can accommodate a wider range of biodiversity and ecological niches. Additionally, a slightly warmer temperature compared to Earth's could result in larger tropical zones on the planet. These expanded tropical regions may foster higher biodiversity, enhancing the chances of sustaining diverse forms of life. However, it is important to strike a balance, as excessively high temperatures can lead to challenges, such as increased desertification. Finding the optimal range of temperatures that maximizes habitability without crossing the threshold into inhospitable conditions is a key consideration. By exploring the possibilities offered by larger planets with expanded habitable surface area and slightly warmer temperatures, scientists expand the scope of habitability beyond Earth-like worlds and open up new avenues for discovering super-habitable environments that may support thriving ecosystems and diverse forms of life. When compared to planets with larger landmasses and deeper oceans, those with fewer continents and shallower water may have a higher potential for habitability. This viewpoint casts doubt on the idea that the presence of larger continents and deeper oceans automatically increases the likelihood of there being life there. On Earth, large landmasses that are situated a significant distance from the planet's oceans frequently lead to the development of expansive and inhospitable deserts. In contrast, smaller continents would have a higher ratio of coastal areas, promoting a greater proximity to water bodies. This would be because smaller continents are more likely to be surrounded by water. This proximity makes the exchange of nutrients easier, which in turn encourages the development of diverse ecosystems and increases the likelihood that environments will be habitable. When compared to deeper oceans, shallower waters on a planet have the potential to house a greater variety of plant and animal life. There is a greater variety of life forms found in the shallow waters of Earth, which suggests that planets with conditions similar to Earth's might be able to support more diverse ecosystems. The discovery of planets with smaller continents and shallower water depths broadens the range of parameters that can be considered habitable beyond those that are traditionally associated with the Earth. By conducting research into these aspects, scientists broaden the scope of potential environments that could support life. This, in turn, increases the likelihood that they will locate worlds that have conditions that are conducive to the origination and maintenance of life. One planet in particular stands out as meeting at least two of the criteria for being a potentially superhabitable planet. This planet was discovered among those that could potentially support life. Its designation is KOI 5715.01, and its distance from Earth is approximately 2,965 light-years. This planet is thought to be approximately 5.5 billion years old and has a diameter that is between 1.8 and 2.4 times that of Earth. Even though it may have an average surface temperature that is a little bit lower than that of Earth, the presence of greenhouse gases may make it possible for it to be superhabitable. KOI 5554.01, which is located approximately 700 light-years away from Earth, is yet another noteworthy candidate. This planet is approximately 6.5 billion years old, is roughly the same size as Earth, and has an average surface temperature of approximately 27 degrees Celsius, 80 degrees Fahrenheit. Because of these characteristics, the possibility of life existing on this planet is intriguing. None of the 24 planets that have been identified as having the potential to be superhabitable meet all of the criteria that researchers have established. Additional research and analysis are required to verify their habitability and establish whether or not they offer more favorable conditions for the presence of life compared to Earth. So that's pretty much all for this video. Subscribe if you want to catch more videos like this.